Hello and welcome to ILS News. Today's top story. The number of bacteria resistant to antibiotics continues to rise. New methods to determine how they're developing resistance so quickly has been deemed as essential. Pioneering research at the University of Southampton might be the answer. Ben Burwood now with more.
Since their first use in the 1940s, antibiotics have been a staple of modern medicine. Now their overuse is allowing bacteria they're supposed to kill to develop resistance. This means that many of our most effective antibiotics can no longer have an effect on their intended targets. Failure to act could result in 10 million deaths by 2050, creating what some are calling the next international health crisis. Public Health England claim that this is in part due to the increase in prescription of antibiotics by up to 32%. Many of our current antibiotics were found by investigating chemicals that bacteria use to fight against each other. Bacteria become resistant to antibiotics through the development of ways to either remove the antibiotics or change them to stop them from carrying out their intended role. Many scientists are now investigating how antibiotic resistance works, in particular how the bacteria can recognise the antibiotic and move it out of the cell. Dr. Declan Doyle of the University of Southampton is part of a new spearhead of research looking into how and why it gives bacteria such a rapid response to antibiotics.
The focus of my research is to try and find the defense mechanism, to overcome the defense mechanism of bacteria. One of the things that they do is if an antibiotic goes inside the cell, it will kill the bacteria, but they have a mechanism in which they can expel that out of the cell.
Unlike human cells, bacteria have two membranes that surround them. The pumps that move antibiotics out of the bacteria are found in these membranes. There are 5 groups of pumps. 4 of them work to move antibiotics from the inside of the bacteria where they can do damage into the gap found between the two membranes. The final group of pumps is on the outer membrane, pumping the antibiotics out of the bacteria altogether and into the surrounding environment. All 5 pumps work together, meaning that if one of them is made to stop working, the others will pick up the slack. Previous research focused on the 5th group of pumps, found on the outer membrane. Recently, more and more attention has been paid to the 4 groups of pumps found on the inner membrane. These pumps provide the bacteria with an immediate response to the antibiotics by pumping them out as soon as they arrive in their cell. Figuring out how these pumps work could be key to preventing the continuing emergence of antibiotic resistance. The previous method of testing how these pumps worked was by adding a coloured tag to the antibiotic and using microscopes to test which pumps could move it around. This method proved to be costly and time consuming. Dr. Declan Doyle has been working on a new method to investigate pump activity. Rather than tagging the antibiotic like before, the new method tags the protein pump. The pump is removed from the membrane and its ability to move specific antibiotics is tested. This means that one tagged protein pump can be used to test the movement of multiple different antibiotics. However, this is only the first step in many towards developing a response to a looming worldwide health epidemic. Ben Burwood, ILS News, University of Southampton.